Good day, this is MTH 101, General Mathematics 1. I will be taking you through study section 3, matrices. Learning outcomes for study section 3. When you have studied this section, you should be able to define a matrix. You should be able to compute addition, subtraction, and multiplication of matrices. And lastly, you should be able to compute the transpose of a matrix. Let's start by first defining what a row and column matrix is, what it means. Row matrix. The matrix in the form A11, A12, up to A1n is called a row matrix, or a row vector, since it has only one row and one component which are ordered. Column matrix is a type of matrix with only one column. It is sometimes referred to as a column vector. You will see the examples of a row matrix and a column matrix. As you can see, example 1. Here we have the first example is showing a matrix with 3 columns. It has 3 columns and it has 2 rows. So that's an example of a matrix. The second example has 2 rows and 2 columns. It means that it has the same number of rows and the same number of columns. The second example is a 2 by 2 matrix. And the third example, as you can see on the slide, has 3 rows and 3 columns. It has the same number of rows and the same number of columns. We call it 3 by 3 matrix. And the last example is called a 1 by 3 matrix. So first of all, talk about the row and the column, and talk about the row. So these are the examples of matrix we have. Let's move on as we talk about equal matrices. 2 matrices, A which is equal to Aij and B which is equal to Bij are equal if and only if their corresponding elements are equal. That is, if A is equal to B, that is, A is equal to B if and only if Aij is equal to Bij for all I and J. Those I and J are representing the number of columns and the number of rows, and the number of columns. Let's see this example. If A is equal to this matrix, 7, 5, 9, x, that's the number of rows and columns, and B is given as that. Find the values of x, y, and z if A is equal to B. Now, the condition of if A is equal to B is very, very important. If A is equal to B, it means that the matrices A is equal to matrices B. So you can write it out in such a way that you have your 7, 5, 9x is equal to y, 2 plus z, and 9 and 1. So that is what that implies. That is what it implies, that this matrix is equal to this matrices. And if you consider the first number, which is the first element in this matrices, which is 7, is equal to y. That is, y is equal to 7, since the matrices are the same thing. If you take the second, on the first column, this first element, which is 9, is equal to 9, and x, which is the second element on the second column, is equal to 1, because the matrices are the same. It's equal to 1. Similarly, your 5 is equal to 2 plus z. That is, 5 is equal to 2 plus z. 5 is equal to 2 plus z. This is an equal to sign. And your z, if you make z dissolve the formula, then you have 5 minus 2. It means that your z is equal to 3. Now, if you substitute all this number into these matrices, you will discover that your y will be equal to 7, and your 2 plus z, remember z is 3, will be 5. So it means that these matrices They are the same. They are the same. Sometimes they can try to test you to see if you know how to go about equal matrices, and they ask you to check if A is going to B. If any element has a different number from its corresponding element in the second matrix, then the matrices are not equal. So they are only equal if and only if A is equal to B. They have the same number of elements and the same number of rows and columns. What about a situation where you have to find if A is equal to B? In this type of matrices, they can't be equal because they do not have the same number of rows and columns. So the first matrices, which is A, is 2 by 2 matrices, and the second matrix is a 3 by 2 matrix. As you can see, that's the number of elements on the first column is 3, whereas this is 2. And on the second column, the number is 3, whereas this is 2. Therefore, A cannot equal to B. So it's as simple as that. Let's move on as we talk about square matrices. Square matrices. We can classify matrices with respect to their configuration and elements in them. When the number of rows is equal to the number of columns in the matrix, then you have M is equal to N. And we have N times N matrix, which is called a square matrix. It has a general form. So as you can see on the slide, that is the general form of the square matrix, where you have matrix A is equal to A11, the first element. That 11 means is the first element on the row of the first element in the row and the column, and the second element is the A12, and so on and so forth. And B is also a square matrix. C is a square matrix. And you can also proceed to find the diagonal matrix. The diagonal matrix is a square matrix of order n such that all elements outside the diagonal matrix are all 0. Is called a diagonal matrix of order n. In other words, a square matrix A is equal to Aij is a diagonal matrix if Aij is equal to 0. Let's check and see. Now, for this example, as you can see, if you are asked to find the diagonal matrix, the diagonal matrix talks about the elements, that is, those elements that are appearing in the diagonal of the matrix. As you can see, you have 4, 5, and 2. Those are the diagonal matrix that we have in example 4. In example 5, the same thing, you have 4, 5, and 2. You can now be asked, as you can see in example 5, to find a trace of diagonal elements. If you want to find that, your trace, which is TR, is equal to the addition of all the diagonal matrix, or of all the elements in diagonal matrix, which is 4 plus 5 plus 2. And when you have that, you get 11. So that is your trace. Let's move on as we talk about other things. What is an identity matrix? An identity matrix or unit matrix, it can also be referred to as unit matrix, is a matrix having all its diagonal elements equals to 1. It means that all the diagonal elements in that particular matrix will be equal to 1. An example is shown on the slide, where you have I2, which has its diagonal elements to be 1 and 1, as you can see. Similarly, I3 has all its diagonal matrix to be 1. this is an example of what we call identity matrix. Okay, let's move on as we talk about more things. If you multiply a particular matrix with its diagonal matrix, as you can see, and it gives you the matrix back, then you have what we call, so if you multiply, as I said earlier on, if you multiply a matrix with its diagonal matrix, you will get back the matrix, it will give you the matrix back. And those matrices that undergo this kind of condition are called identity matrices, as you can see in example 7. By multiplying the identity matrix of matrices A, by multiplying it with its identity matrices, you get the matrices back. It does not change it. Let's move on as we talk about zero or null matrix. An M by N matrix in which all the elements are zero is called a null or a zero matrix. That is Aij. The I stands for row, while the J stands for column, is equal to 0 for all I's and J's. So as you can see in example 8, all the elements are 0. So that is a null matrix. Let's move on as we talk about the transpose of a matrix. If A be an M by N matrix, then the transpose A, denoted by A superscript T, is a matrix of order M by N obtained from A, such that the entry Aij of A superscript T for all I and J. Simply put, the transpose of an M by N matrix A is a matrix of order M by N obtained by interchanging the rows and columns of matrix A. That is, Aij is equal to Aj for all I and J. And if you look at this example, this simple example given in the slide, you have A11, which is representing a matrix, and AI2, you have A21 and A22. If you transpose it, when you're talking about transposition of matrix, you are talking about the interchanging of the row with the column. It means that your row will become your column and your column will become your row. And that was what we did here by changing these elements to be your column and changing this column to be your row. It's as simple as that. That was how we obtained this. A11 becoming this row, now becoming this column becoming row, and this column becoming the row for 2 by 2 matrices. Let's see another example how we can obtain a transpose of a matrix. Considering A, the first matrices, when you have your A to be 2, 1, 3, 2, and 6, those are the elements. It means that you want to make this column to become your row. You want to transpose it, and transposing it, you have them as your row here. While 1, 2, 8 here, which is a column matrix in matrix A, they are transposed to become row here. Similarly, if you want to do a 3 by 3 matrix, what you will do is to transpose this column. When you transpose this particular column, they become a row here, as you can see it. As you can see it here, they become your row. They become row matrices here, as you can see it. And this column, this particular column becomes row here, and this particular row becomes column here. That's what we call transposition. But the little difference for a 3 by 3 matrix is that, out of these 3 by 3 matrices, you can say have a 2 by 2 matrices. You will not leave it without changing it, you are transposing it. What you do is to transpose this side of the matrix so that this row become a column and this column become a row, and that is what we did here by 5 coming here and 1 coming here. So you just do you interchange it. That's a simple way of doing it so that it will not confuse you. It's not going to confuse you. So that is how we have our CT to have 17, 8, 1 as the first row, 3, 0, 1 as the second row, minus 1, 5, 4 as the third row. So we transpose it one after the other. Let's move on as we talk about matrix operations. Multiplication of a matrix by a scalar. Suppose K is a number and A is equal to AIG. Is an n by n matrix. Then the product B is equal to K. That is multiplying by the scalar. Is an m by n matrix obtained by multiplying A by K. What are we talking about? What you are going to do in such example is if you want to multiply this particular matrix by a scalar quantity, which is 3. What you will do is to multiply each element in the matrix by a scalar quantity, which is 3. And if you do that, you will obtain your A will become your A. Now your 3A now will be equals to 3 multiplied by 2 and 3 multiplied by -1 and 3 multiplied by 6 and 3 multiplied by 5. So at the end of the day, you are going to obtain your matrices, new matrices, which is 3A to be 6 minus 3, 18 and 15. So that is the multiplication we are talking about. So it's as simple as that. That is how you can obtain the matrices by multiplying by a scalar quantity. Let's move on as we talked about more matrices operation, and we are going to talk about addition and subtraction of matrices. 2 or more matrices of the same order, say m by n, can be added to form a new matrix of the same order. That is, 2 or more matrices can be added together if they have the same number of rows and columns. You have to take this into consideration. You can only add 2 matrices if they have the same number of columns and rows. Otherwise, you cannot add. Like for example, you cannot add a 2 by 2 matrices with a 3 by 3 matrix. You can't add them together. You cannot add you cannot subtract a 3 by 3 matrix from 2 by 2 matrices. So they must have the same number of rows and columns. Here's an example of the addition of the matrices. What you do, as you can see, is to add matrix A to B, add it together, and with that you will be able to, what you will do is to add the first element in the first matrix with the first element in the second matrix. The first element in the first row of the first matrix will be added to the second element in the second row of the second matrix. I hope that will not confuse you. What I'm saying is that you add this first element to this first element here in order to compute your A plus B, and if you do that, it means that you have your 1 plus 1 is equal to 2. Similarly, you had the second element in this first row with the second element in the first row of the second matrices. You are going to have 3 plus 5, which is equal to 8. You had the last element, the first row of the first matrix, to the last element in the first row of the second matrix. That is 4 plus 10, which is going to be 14. We are going to repeat the same procedure for the other elements. So 1 plus minus 2. This is going to give the -1, 2 and 6. 2 and 6 is going to give you 8. 5 and 3 will give you 8. 6 and minus 7 will give you minus 1. Will give you minus 1. 2 and minus 1 will give you 1. Where 8 and 4 is going to give you 12. So with this, you have computed the matrices A plus B. You can follow the same procedure for the second example, where you are going to subtract 2 minus 5, minus 6, and minus 4. I hope you are going to try that. Just get a sheet of paper and work it out and see if you are able to get that. Let's talk about multiplication matrices. Two matrices A and B can be multiplied if and only if the number of columns of A is equal to the number of rows of B. So this is a big difference, although they may have the same number of rows and columns, but when condition is fulfilled, then you should know that you can still multiply them. What you will do in this case is to multiply this particular row So if you want to do that, just use a simple mathematical formula to do that. That is row. You have your row times column. What you will do is to multiply this row by column. Do the same thing. Repeat this row for this particular element. And secondly, you repeat this for this for this for this particular row, and this for this particular row, in order to get your A, B. So what you will do now is work it out. For the first step, it will now be 3 multiplied by 2 plus 2 multiplied by 4. And your second element in the second column will be 3 multiplied by 3 plus into brackets 2 multiplied by 1. Repeat the same procedure for the second row in the first matrices. Here, it should not be 4 multiplied by 2 plus into brackets 4 multiplied by minus 1, and then 4 multiplied by 3 plus into brackets minus 1 multiplied by minus 1. You repeat the same for the last row here. It's now going to be 5 multiplied by 2 plus 4 into minus 3, and then 5 multiplied by 3 plus minus 3 multiplied by minus 1. So if you work this out, you get the elements, different elements in this matrix AB. I want you to work that out and see what you will get. In the subsequent study sections, you'll be introduced to more things. I hope you have learned 1 or 2 things. Thanks for listening.